Okay, so we're working with quadratics right now, and they've given you this formula here. And what this is a quadratic formula or a parabola, and it's in a specific form. Okay, so if you look over here to our right, we have standard form, factored form, and something called vertex form. Now we're not going to really work with vertex form. We're going to focus on standard and factored today. Okay. Now I want to draw a comparison between the two, so we're going to bring this over here so you can see what this looks like. Standard form is actually what this question is in right now. Okay. Now what I want you to be aware of is besides the x and y variable, they have three other letters representing numbers. They have the a, which would technically be just a 1 in this equation. They have the b, which would be 5. And they have c, which would be the number 6 in this equation. Okay. Now in standard form, it's very tough to graph a quadratic. So one of the things we want to do is they'll talk about zeros eventually and graphing them. So this is a rough idea here. This is kind of like our xy axis. And eventually we're going to want to plot points on this. Okay. Well, when I go to draw a parabola, let's get an example here. It's going to look something like this on the page. And what we want to happen is we want to be able to, there's some major parts of parabolas. Two major parts. Yeah, our two x-intercepts. That's right. So we have our x-intercepts, which are those two there. The axis of symmetry, you're right, is another major point. It looks like it's going to be like roughly there on this one. And another big point would be the vertex of this guy. Okay. Whoops. The vertex. Oh, seems to be doing that. Oh, I know why. Sorry. Now we'll just leave it. There it is. That's what I was looking for. So, and there's our vertex. Okay. Sorry, and there is actually another major point which we've kind of left out here, and we can tell. It's going to be a little tough. Yeah, the Y-intercept is another major point. So essentially when it's going to cross, it just looks like it's right beside the vertex, when it's going to cross the Y-axis. So major points are x-axis, vertex, and y-axis. Now in standard form, we can find one of these numbers easily. Okay? And it turns out the number we can find easily is actually our Y-intercept. And the reason we can find the Y-intercept really easily is because to find a Y-intercept, that's when our x value is 0. Okay? So in standard form, we have our y equals, and instead of writing an x, what we're going to do is we're going to replace all the x's with the number 0, because that's when the value of x is 0. So plus 5 times 0 plus 6, technically. Okay, so I replace the other x with 0. So we've replaced both of the x values with the number 0. Okay? So what we're going to get here, y equals 0 times 0 will just be 0. 5 times 0 will just be 0, and plus 6. So y is equal to 6. So in this specific case, and now this isn't a good example, we just sketch this one on the side when we put little lines around it, so we know that this is just an example. This isn't exactly showing us. But in our parabola over here, the y-intercept is actually the point of 0 and 6. And the easy way to tell that from standard form is we just actually look at our constant term. Okay? And what we mean by that is this term here, 6 would tell us exactly what our y is. So when we're in standard form, we can just look at that to find out exactly what our y-intercept is going to be. Okay? Okay, so with that being said, what we're going to do is we're going to start to sketch our own graph here. Right, so we'll bring up a graph, scale of 1. Yeah, that should be fine. So let's bring this graph down. Okay, so we have our graph here, and we know our y-intercept is going to be at 0 and 6. So I'm going to plot that point already. We're going to have a point right here. That's where it's going to cross the y-axis. We figured that out from standard form. Now that's the only thing we can look at standard form and easily tell is this point here. So now what we're going to do is we're going to work with standard form, and we're going to turn it into what we call our factor form over here. Okay? So, our original question was y. Oops, y is equal to x squared plus 8x plus 15, right? Oh no, plus 5x. What am I saying? 5x plus 6. Yeah. Okay. So we're in our standard form right now, and our goal is to change this form exactly into our factored form. So I'll put it up here, and we'll bring standard over here too, just so you have an idea. Now, there's a way to do that. Okay. In fact, there's a way to go from one to the other. To go from standard to factored form, we factor. Makes sense with the name. To go from factored to standard, we actually do something called expanding, or expanding and simplifying. Okay, so that's how we move back and forth between the two forms. They still represent the exact same parabola on a graph. They just look differently. Now, in order to factor, there's many ways we can factor. I'm going to assume your teacher has taught you a way where you find two numbers that multiply to your C term, which is your 6.
C meaning constant, right?
Meaning the constant, yeah, exactly. And I'm going to call it C just because that's what we called it here. Right? And those same two numbers need to add up to your middle term, which we call the B over here. Is that how they showed you to factor? Something like that? There's many ways to factor. Okay? So in this case, I'll show you that. And now the reason this works, this style of factoring, it's a very simple style, is because right now your A value is the number 1. If it wasn't the number 1, this style of factoring technically wouldn't work. There's a little more that has to be involved in it. Okay? Now I can show you the rule that would work even if this wasn't 1. It's a little more complex. What we do here is the more complex version is instead of just multiplying to C, we multiply to A times C. Okay, so I'm just going to erase this. And what I mean by that is our A value, which is here, in this case is the number 1, right? And our C value is the number 6. So we call it AC. It's technically two numbers that are multiplied to AC. And what AC is A times C is what that means. Okay. Now the reason you've probably been told that it's just the C is because when A is 1, 1, which is A, times C, which is 6, 1 times 6 is still just going to be 6. Okay? If this wasn't the number 1, then we'd have to abide to this type of rule. Okay? And it gets a little more complex even from there. But for now, let's kind of go with that. So we need two numbers that are going to multiply to 6 and then add up to our B term, which is 5. So let's rewrite this a little so it's a little nicer. So I need two numbers that multiply to 6 and add to 5. Can you think of any?
Two numbers that multiply to 6 and add to 5.
Yes.
3 and 2.
Yeah, that's right. 3 times 2 will multiply to 6, and 3 times 2 will add to 5. So now we just jump straight into our factored form. So I'm going to rewrite our question above. 5x plus 6. And now what we do, y is equal to, we have our brackets, and they use an r and an s. We're going to just replace those r's and s. We put x's as the first term in each, and plus 3 in one of them, and plus 2 in the other. So this will be our factored form. Okay. So we did that style factoring. We took the 3 and the 2, and we put them in here. So we took our 3 and our 2, and they become the second terms in each bracket. Okay. So what's good about factored form is it's easy from factored form to find our X-intercepts, okay, which we talked about over here. These are our X-intercepts. We can find those easily in factored form. What we're going to do is there's many ways to describe this. Many people just look at the bracket and they take the opposite. So because this is positive 3, many people will be like, okay, one X-intercept is negative 3 and the other one would be negative 2, which is correct in this case here. The reason being,
Wouldn't it be positive?
they're actually going to be the opposite of the two numbers. And the reason being, I'm going to show you exactly why this happens. See, the reason for this is because remember when we found our Y-intercept? we technically set the variable x equal to 0, right? Well, in order to find an x-intercept, we're going to set y equal to 0. Okay, so we jump down to our factored form. This y is now going to be set equal to 0, opposite of what we did to find our y-intercept. So y equals 0. So what that's going to mean, I'm going to move some stuff over so it's a little cleaner to look at. And what that means is we're going to get 0 is equal to, and we're going to keep our factored form, x plus 3,
But I
x
still
plus
don't
2.
know why it's negative now.
And I'm going to get to that. So we have these two here. Technically what this means is this bracket multiplied by that bracket. Well, this is saying that when I multiply these two brackets, we get the number 0. In order to multiply something to 0, one of the numbers have to be 0. You can't multiply any other numbers and get 0.
Yeah.
So one of these has to be 0, and what we do in this case is we think of both possibilities. Okay, so maybe both of them are 0. Or we have to figure out, at least if each was 0, what the answers would be. So I take one bracket and the other bracket, and I set them both to 0 themselves. Okay, so it becomes almost like two questions now. So we get 0 is equal to x plus 3, and 0 is equal to x plus 2. And now I solve for x. So I move the 3 to the other side of the equation. When I move 3 over there, what does it become?
Negative?
Negative 3, which is x equals negative 3. Now when I move the 2 over, I get negative 2. So just like in our answer, where we had negative 3 and negative 2, that's exactly what we solved. So a lot of people will tell you the shortcut, okay, just look up here, and whatever's in there, the plus sign, change it to a negative. Right?
Okay.
And again, that only works if there's a 1 in front of this x. If there's a different number, then it's all different once again. Okay? So a lot of information we just went through there. Okay, so we're going to move on to finding a y-intercept. We did that in the last one. We're going to try to be a little more organized and a little more specific. So in this question, we're finding the y-intercept. We have a different example here. In order to find a y-intercept, we have to set one of the variables equal to 0. Do you remember which one it is by chance?
I have to find the x, put the x into 0.
Yes, that's right. So it's the opposite of what you think. Even though this says y-intercept, we actually set x equal to 0 in order to solve it. So I go through this question now. Y is equal to squared minus plus. And what we're going to do is I'm going to replace this x with 0 and this x with 0. Then we're going to work it out here. Y is equal to 0 squared is 0. Negative 11 times 0 is still 0, plus 10. So your y value when x is 0, that's what this means. Y is equal to 10 when x is equal to 0. So when x is 0, y is positive 10. And that's our y-intercept, which would be, when we go to graph it, that's when the parabola crosses. Oh, that was not a good example. Let's do a little better. There it is. That's something like that. Okay? That's just a rough estimate. We don't know what's exactly there. But that would be the point at 0 and 10. Okay? Now on our next page, what we're going to do here is we're going to look for the x-intercept. So finding x-intercepts. This is more complex. Okay, we're going to take the same question, y is equal to x squared minus 11x plus 10, and we're going to talk about what we need to do. So in this one here, the first thing we need to do is we take the standard form, and which is exactly what it's in, and we got to factor it. And we have to put it into factored form. Okay? And remember, in order to do this, we factor. So, when we factor, we're looking for numbers that add up to our constant, multiply to our constant. So two terms that multiply to our constant, which is 10, or we call it the C. So in this case, we're going to say C. And two numbers that are going to add up to our B, or negative 11 in this case. And this is the B. Okay? So we got to think about this. Two numbers that multiply 10 and add to negative 11 here. Okay? So I'm thinking, this is tough. I could use, let's trial and error. 2 times 5, that gives you 10, but 2 plus 5, does that give us negative 11? No. And let's think of the opposite also. Negative 2 times negative 5 will still give me positive 10. Negative 2 plus negative 5, well, no, that gives me negative 7. So that won't work either. The only other ones I can think of is 1 times 10 and 1 plus 10. Do those work? Oops.
It'd be would it be negative?
Won't give us negative 11, right? But if they're both negative, so let's try that. Negative 1 times negative 10 is positive 10 still. Yeah. Negative times a negative. Negative 1 plus negative 10 is negative 11. So those are the two that'll work. So we take those numbers. Remember, we set two brackets, and x is the first term in each. And we take those two numbers, and we input them in the brackets. So negative 1 and negative 10. And now we're in factored form. So we've just changed in the factored form. But we're not done. Because remember on the other page we said to find a y-intercept we set x equal to 0? Well, to find an x-intercept, we have to set y equal to 0. So I'm going to replace the y in this question with the number 0. So 0 is equal, and we have to be in factored form in order to solve this. Our two brackets. And remember I said it's a bracket times a bracket. So the only way to get a 0 by multiplying is if one of these is 0. So we break this into two parts. X minus 1 equals 0. X minus 10 equals 0. And I move the 1 over. X equals positive 1. And x equals positive 10. Because we move negative 1 over, it becomes positive. Does that make sense? And we move negative 10 over, it becomes positive 10. So those are the x-intercepts, which when we go to graph again, oops.
So the y-intercept, when it says y-intercept, find the y-intercept, we're really finding the x-intercept.
Well, no, we're finding the y-intercept, but we're setting x equal to 0.
Oh, okay.
Okay. And what that means is it's probably going to be something like, yeah, that's a good representation. So, one of these points is 1 and 0. It's the x value. And the other point is 10 and 0. Right? And the reason the other points are 0 is because we set y equal to 0. We found our x values when y was 0. Our two x values were 1 and 10. So again, a little recap here. We set our y-intercept, we set x equals 0. For x-intercepts, we set y equal to 0.
Okay.
Y-intercept's really straightforward, you just plug it in. In the x one, we can't just plug it in because from standard form, it's too hard to tell what the numbers will be. We actually have to factor it. So we factor it, and then when it's set equal to 0, we split those two brackets up and solve for what the x-intercepts could be.